Alright guys, this is the video for 4-6. Now this is the last section of chapter 4. Like nothing new is going to be talked about here, it's just kind of compiling everything and putting it all together. So there's nothing that we're going to paste into our interactive student notebook, so it's just this one note sheet which is front and back, which is 5 examples. What I want you to do first is for the first 3 examples, kind of like I did, go ahead and write out the points in the examples which come straight from here along the left side, and then go ahead and plot them. So you can see I've done that here, and here, and here. So just to help speed things along, go ahead and do that for these first 3, and then we'll dive into it. Alright, so back to example 1. Hopefully you have marked the coordinates on the left, and then you've also plotted them. So notice we're doing 2 things. In all of these we have a composition, so we have more than one thing. So the first thing we're going to do is a translation. So I'm going to call this A prime, B prime, and C prime. Okay, so what I'm going to do is I'm going to add 5 to every x coordinate. So -4 plus 5 is a positive 1, -2 plus 5 is a positive 3, and a -2 plus 5 is also a positive 3. And then I'm going to add 1 to each y coordinate. So 1 plus 1 is 2. 2 plus 1 is 3. And then 1 plus 1 is 2. So go ahead and plot these. Make sure to label them A prime, B prime, and C prime. Alright, so after you've plotted it, it should look like this. Now remember, in words, this tells me I moved right 5 and up 1, so if you count the coordinates or count the boxes, you should have gotten that. Alright, so next I'm going to have a dilation and it gives me my rule. So remember, when it's written like this, that just means I'm dilating by a scale factor of 2, which means I'm multiplying each coordinate by 2. So I'm going to get A double prime, B double prime, and C double prime. So I'm going to multiply every single coordinate by 2. So 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 3 times 2 is 6. 3 times 2 is 6. 2 times 2 is 4. Now go ahead and plot these 3 points. Make sure to label them A double prime, B double prime, C double prime. So after plotting them, this is what you should have gotten. Alright, let's look at example 2. This should be a 90 degrees, not a 900 about the origin. So I already have my C and my D, which you should too. I already have it plotted. So I'm going to find my C prime and my D prime, which, as we can see, that's a rotation of 90 degrees about the origin. So what we first need to do is go back through your foldable and look to find what is the rule for a dilation of 90 degrees about the origin. Okay, if you look, the rule for that is AB goes to negative B, A. Okay, remember, this is my A, this is my B. My A, this is my B. So my C prime, if I go negative BA, so negative B would be a -2. My A is a -2. And my negative B is a -2. And then my A is just a 2. So if I plot this, I get 1, 2, 1, 2. So this would be my C prime. And then -2, +2. The point that was originally my C is now my D prime, which is perfectly fine. And then I'm just going to connect the dots. Okay. Now I want to dilate it using this rule. So if you look, my scale factor here is 1/2. So remember, all that means is that I'm going to multiply every coordinate by 1/2. So -2 times 1/2, -1. -2 times 1/2, -1. -2 times 1/2, -1. 2 times 1/2 is +1. So if I go and I graph this, so -1, -1. Here's my C double prime. -1, +1. It's my D double prime. Here's my C double prime, D double prime. All right, let's look at example 3, which you should have these points already written here, and you should have it already plotted. So the first thing we want to do is we want to reflect it over the x-axis. Now I need you to go through and look through your interactive student notebook and find the rules to reflect something over the x-axis. All right, when we reflect something over the x-axis, my rule is AB goes to a negative B. So I'm staying in the same order. I'm just reversing the sign of my y coordinate. Okay, now if it's already a negative, it goes to a positive. It's a positive, it becomes a negative. So using that, my A prime is A is 1. My negative B is a negative 2. My B prime is, my A is 4. My negative B is negative 4. And my C, my A is 2. And my negative B is negative 0, which is just a 0. So go ahead and plot these three and make your new triangle. All right, so when you do that, you'll notice your C and your C prime are in the same exact spot. That's okay. Just make sure you write both C and C prime there. All right, so now that we've reflected it, we need to dilate it. Okay, now my rule here is 1/2 x, 1/2 y, so I'm going to multiply each and every x, y coordinate by a half. So I'm multiplying it. I have a scale factor of 1/2. So my A double prime, B double prime, C double prime. Okay, if I multiply 1 times a half, I get 1.5. Negative 2 times a half is negative 3. 4 times 1.5 is 6. Negative 4 times 1.5 is negative 6. 2 times 1.5 is 3. 0 times 1.5 is still 0. So go ahead and plot these 3 points. So after you plot it, this is what you should have gotten. All right, so before we look at examples 4 and 5, I want you to go through and, like here, we're starting with PQRS, so I want you to write the coordinates of PQRS, just grab them straight from the coordinate grid here where it's already plotted. And then I want you to do the same thing with the other figure, WXYZ. Make sure you go in order and get that just from the graphing here. Okay, so do that to that. And then also do that to DEFG and STUV. Make sure to put a space in the middle because each of these have more than one transformations that we're going to do. So do that real quick and then we'll go over them. All right, so if I go back and I look at example 4, my starting points are listed here in blue, and what I want to end with is listed here in green. Okay, so I'm going to have to kind of look at these and try to find a pattern here. Okay, well, I'm going from negative 6 to 3, or negative 6, 3 to 2, 1. Negative 3, 3 to 1, 1. I notice that they're different size. So at the very, very least, I know I have a dilation. Okay, so let's take care of the dilation first, and then we'll worry about whatever else that follows. Okay, so I don't care about my negatives and positives. How do I go from 6 to 2? How do I go from 3 to 1? Well, I'm dividing both sides by 3. Which is the same thing as multiply by a third. So if I first dilate each point by a scale factor of a third. Okay, so let's do that. So if I dilate by a scale factor of a third, that just means I'm multiplying each of these by a third. So my P prime, my Q prime, R prime, S prime. So if I multiply negative 6 by a third, I get negative 2. If I multiply 3 by a third, I get positive 1. Negative 3 by a third, I get negative 1. 3 by a third, I get positive 1. 0 by a third, that's just 0, guys. Negative 3 by a third is negative 1. And if I get negative 3 times a third, negative 2, negative 3 times a third would be a negative 1. Okay, now I'm one step closer. Okay, so if I look from my P to my, or my P prime to my W, from my Q prime to my X, R prime to my Y, S prime to my Z, what you'll notice is that this goes from a negative to a positive. My last one stays the same. This goes from a negative to a positive. My last one stays the same. Well, 0 is just 0. My last one stays the same. This goes from a negative to a positive. My last one's the same. So the rule I get is A, B goes to negative A, B. Okay, so if you go to that rule sheet and you look, what tells us to do this? As we can see on our rule sheet, this is just a reflection over the y-axis. Okay, so first I'm going to dilate by a scale factor of 1/3. Second, I'm going to reflect over the y-axis, and that is it. All right, using the same type of reasoning here, I want you to go ahead and try this one on your own. It does take some thought process, so don't give up in 2 seconds. I want you to think through it, try to figure it out, and then I'll go over it and I'll explain it. All right, this is what you should have gotten for the last one. You should have seen first that it was a dilation by a scale factor of 1/2. So after you dilated it by a scale factor of 1/2, which basically means you multiply each coordinate by 1/2, you should have gotten what's here in red. And then by comparing the last two columns, you should have known that we're just switching the sign of every x coordinate and every y coordinate. So from that, you could find what your rule is, okay? So AB goes to negative A, negative B. And then I went in on my foldable and I looked, well, where do I see the rule AB goes to negative A, negative B? And I seen that's when we rotated a figure 180 degrees. So that's what I did.